Hello and welcome to today's class. Let's look at yet the third method on evaluating the limit of a function. The third method is known as limit at infinity. By the way, there's a symbol we use for representing infinity in mathematics. So this symbol here is actually a symbol or perhaps symbolic representation of infinity, as I have here, right? So either being given a positive infinity or negative infinity, how do you possibly evaluate problems when it comes to infinity? The task is quite simple, right? The key concept there is just that I'll divide. Let's say you're given a function. Your first task is to identify which variable has the highest power. That's the condition there. So when you get out the variable that has the highest power, you simply divide through or divide by the highest power. So basically, I'm saying that when it comes to evaluating problems under the infinity concept of limit, you divide through by the highest power. When you are done with that, you put x at 0, and that's all. Right? So we'll take some few problems and we'll see how we can possibly evaluate those problems applying the concept of limit at infinity. Let's look at how we can possibly evaluate this particular problem here. So I'm given that the limit of 3x plus 5 all over 4x cubed plus 4 as x tends to or perhaps approaches infinity. How do you possibly evaluate this problem? We said the very first task is to identify the variable with the highest power. Solution here. Solution. In this case here, which variable here has highest power? Of course, x cubed has the highest power here. So that's that I'll divide through by the variable with the highest power. That's the concept. So here's the thing. I have the limit as x tends to infinity. The one is given as 3x plus 5 all over 4x cubed plus 4. Oh, my highest power here is what? X cubed is simply the highest power here. So I'll divide each of the terms in this function by the highest power. So what is first? From here, this is first term here, that's 3x divided by the highest power, which is what? X cubed plus 5 over the highest power is x cubed, so divide by x cubed. So divide each of them by x cubed all over, I'm having 4x cubed here, 4x cubed all over what there, divided by x cubed as we said initially, plus, this is 4 all over what there, x cubed. So I have this, right? So my next task now is that I'll simplify as possible as I can. If this s cancel x cubed, I'll have x squared left. So I'll be having 3 over x squared left plus, this is 5 over x cubed, remains the same. So I'll have 5 over x cubed. Of course, there's no x attached to this 5, so I'll just repeat it down back. So all over x cubed will cancel x cubed. I'm having just only 4 left. So 4 is the left value here, plus 4 over x cubed will remain the same, 4 over x cubed. So after simplifying this way, the next task is what? Put x as 0. Put x as what? As 0 into the function. So here I'll have 3 over 0 squared plus 5 over x cubed, that's 0 cubed, all over, I'll have here as 4 plus 4 over 0 cubed. By the way, I shall have 0 plus 0 all over 4 plus 0. From here, I'll have 0 over 4. This is now equal to 0. So in this case here, after evaluating this problem, right, using the concept of infinity, we said the task there is just divided by the ix variable. The ix variable here, or perhaps ix, the ix variable here is s cube. So just divide through by s cube and then put s as 0, and my answer gives 0. As easy as that, right? So this is how to evaluate problems when it comes to limit of a function. We'll take yet another example and see how you can possibly do the stuff using infinity. Welcome back. Let's try this yet example 2 to further increase the in-depth understanding of how to evaluate problem using the concept of limit at infinity. So we said your best task when you see a question when it comes to infinity is to identify which variable has the highest power, or if you want to, highest index or highest degree. So which variable here has the highest power? Of course, it's clear that I have x to the power 5 is the highest power here. So the task is now I'll divide each of the term here by the highest power. That's all. So solution to this problem here, my first task here is that I'm given that the limit as x tends to infinity, the question given as 6x to the power 5 minus 4x squared plus 3 all over 11x to the power 5 plus 2x to the power 4 minus x. Of course, my x power is given as what there? X to the power 5 is simply my x power. So I'll divide each of this term by the x power. So pick up 6x to the power 5. 6x to the power 5 over that x power is x to the power 5 minus, this is what? 4x squared over the x power there is what? X to the power 5 plus 3 over what there? X to the power 5. I have this, the first task for numerator, all over, check your denominator. I have 11x to the power 5, so 11x to the power 5 all over x to the power 5 as being the x power plus 2x to the power 4 all over what there? X to the power 5 minus x all over what there? X to the power 5. So I have this. Alright. Proceeding from here, I'll simplify this as fast as I can. What do you observe? This cancel this. So I'm having just only 6 left here. 6 minus this cancel this. I'll have 3 of it left. That becomes 4 over x cubed left plus this does not have x, so repeat it back. That becomes 3 over what there? X to the power 5. I have this. So all over this should cancel this as expected through mathematical approach. So I have 11 left. 11 is left here. Plus, if this cancel this, I'll have one of it left here. So I have 2 over x left minus this cancel this, I'll have 4 of it left. So that becomes 1 over what? X to the power 4. We said after doing this, what next? Just put x as what? At 0. So put x as what? 0 into the function back. So this becomes what there? This should become 6 minus 4 over, I'm seeing x, put 0 cube. Next up, plus, this is 3 over 0 to the power 5 all over, I can see 11 clearly, 11 plus 2 over, anywhere you see x, please put what there? Put 0 as established, 0 minus 1 all over, I'm seeing x to the power 4, that becomes what there is 0 to the power 4, right? So the thing, this is not equal to, I'll have 6 here. By the way, if 4 divides 0 is not proper in maths, I should have explained when I was in the initial example. In mathematics generally, it's not proper for the denominator to be down this way. If you take a calculator and you press 4 over 0, you have math error. It's not proper for the denominator to be 0. So it's proper if I have 0 over 4, I'll have 0. But if I have 4 over 0, it's math error. Use a calculator and check. So by the way, I'm meant to have infinity, right? But the task is that I'll just put x as 0. So I'll assume that 4 over 0 should be 0, so that I can actually get what I'm actually looking for. That's the task. But just normal in math, if I have 4 over 0, it's not correct. It's wrong. This is math error. But if I have 0 over 4, it's proper this way. I should have 0. And if you observe our first example, I end up having 0 over 4 to observe very well. That's why I had 0 as my answer for the initial example we did earlier. So that's like the concept behind this. So in this case, I just put 0 there, minus 0 plus 0 over what there? 11 plus 0 minus 0. So in this case here, from your math concept, this should give what? 6 over 11. So it becomes how to evaluate problems using the concept of limit at infinity. So let's look at yet the fourth method called L'Hospital's rule, and then we'll look at yet several other methods.